Web2Print, a flexible and cost-effective solution for ordering and robotic handling of textiles and soft materials. We were given the following challenges by our challenge provider: make their high-mix, low-volume production more efficient, increase automation, and reduce existing warehouse area by half. A solution to this is Web2Print manufacturing software, which streamlines the production process and reduces the amount of manual labor. Web2Print is a cloud-based software. It automatically combines orders into batches and generates ready work files for laser cutting machines. It also generates pick and place coordinates for robots on the fly. No laser or robot programming is needed. Orders can be received in 3 different ways: from variable data, for example incoming from integrated factory MES or ERP system, from a partner in subcontractor network, or from an online editor, which can be integrated, for example, with e-commerce sites allowing mass customization. By automating manual steps and using fast laser technology, we can reduce lead times and setup times. Products can then be manufactured on demand, which results in smaller warehouses and leaner production. In the online editor, users can define any of the needed parameters of the parts. The user can change the size, shape, material, and quantity of parts. Text and image engraving can also be added. The web-based editor is ideal for e-commerce site integration or ordering just a few customized parts. Web2Print can read Excel and CSV files and automatically generate a large amount of items from the variable data. This functionality can be used to integrate Web2Print with factory MES or ERP systems. Web2Print orders can be found under the job menu, from where they can be moved to production. The incoming jobs can also be sent to a subcontractor. An operator can select which of the jobs will be sent to production. Web2Print automatically nests the parts and sends a work file to the laser cutter. The laser starts working automatically and requires no human interaction. Using a laser cutter improves safety, as workers do not have to use manual tools such as bandsaws. The third component of our solution is a collaborative robot. The robot can adapt to a changing environment, as it can recalibrate itself using machine vision. The robot can be mounted with different kinds of grippers. For textiles, we have elected to use a needle gripper. The gripper has adjustable needle depth, so it can be used with thick and thin materials. The robot can also be equipped with a vacuum gripper for picking up solid parts. The robot is human-friendly and does not need to be gated like traditional robots need to. Robot will enter collaborative mode if humans are close to it. If the collaborative robot hits a human, it will automatically stop. After the cutting process, the robot picks up the cut items and sorts them by either shape or order. Most importantly, robot requires no new programming in between orders or product changes. In case there are different sized parts within an order, they are stacked from largest to smallest. The robot can sort parts perfectly using the data and coordinates from the system. This makes more complex and efficient nesting possible, as a human would have difficulty sorting parts from different orders placed randomly around the sheet. Locating objects is not dependent on lighting and machine vision, which makes the system reliable and easy from integrator's perspective. Guild and Enecos present a solution for more efficient manufacturing process.